Differentiation Example 6. Make sure you have read the notes preceding Example 6. In particular, make sure you know what a tangent is. So it's a line that has the same gradient as the curve at a given point. And make sure you know what we mean by a normal. So a normal is a line perpendicular to the tangent at a given point. In your notes, you have the two procedures for finding any tangent to any curve, and then procedure to find any normal to any curve. They're very, very similar, just one extra step with the normal. So let's have a go. Example 6, find the equation of the tangent to this curve at the point where x is 2, and then sketch the curve and show the tangent at the point x is 2. So here the function is f of x instead of y. So when I differentiate it, I call it f dash or f primed. It's ready to be differentiated, so let's get straight on with differentiating it. So f dash of x is 2x take 7. We want to know the equation of the tangent at the point where x is 2. So I'm going to put 2 into that function. So f dash of 2 is 2 times 2 take 7, which is 4 take 7, which is minus 3. This is telling me the gradient of the curve when x is 2. Now whatever this curve looks like, its tangent at the point where x is 2 definitely has a gradient of minus 3. So following the procedure in your notes above, we've done step 1. Now we need to do step 2. We know the gradient, we just need to find the equation of the line. So y minus y1 equals m brackets x minus x1. Make sure you write down the formula before you sub the numbers in. Now the gradient is minus 3, and this is the gradient of the curve at the point when x is 2. So we know the gradient, we know half of a point on the line, we know x is 2, but we don't know what y is at the moment. So let's go back and find the value of y when x is 2. We're going to need that to finish off the equation of the tangent. So when x is 2, y, which is effectively the same as f of x, it's going to be 2 squared, which is 4, take away 7 times 2, which is 14, and then add 10. So we have 10 plus 4, which is 14, take away 14, which is 0. So this line goes through the point 2, 0. Let's sub all that data in. So the gradient is minus 3. And it goes through the point 2, 0. X is 2, y is 0. So x is 2, y is 0. I'm just going to tidy this up a little bit. So on the left-hand side, I've just got y. On the right-hand side, I'm going to expand the brackets. Minus 3x plus 6. Find the equation of the tangent at the point where x is 2. Done. Sketch the curve now and show the tangent at the point where x is 2. So sketching the curve, I'm interested in where might it cross the x-axis, where might it cross the y-axis, is it a U-shape, is it an N-shape? Need to consider all those things. So first of all, it's a positive x squared graph, so therefore it's going to be a U-shaped graph. Let's figure out where will it cross the x-axis, if at all. Well, looking back at the original function, it would cross the x-axis when y was 0. And again, y is effectively the same as f of x. And notice in the right-hand side, will factorize. So this tells me that when x is 5, this will equal 0. And when x is 2, all of this will again equal 0. So it crosses the x-axis when x is 5, and again when x is 2. That's enough information for me to start drawing it. So it crosses the x-axis when x is 2 and when x is 5. Let's show where it crosses the y-axis. At this point, we know x is definitely 0. So when x is 0, y is 0, take 0 plus 10, so y is 10. We need to do one more thing. We've sketched the curve, but we need to show the tangent at the point where x is 2. Do you remember early on we found that when x is 2, y was 0? Well, our graph has just confirmed that. When x is 2, yep, we get a y value of 0. And we worked out the gradient of the curve at that point. It was minus 3, sloping downhill. And again, the graph confirms that. And we've got the equation of the line at that point. So all I need to do now is show that line. So the tangent will just touch the line at that single point. Now my curve's not super smooth, but make sure you understand that the curve and the line touch at a single point, at that point there where x is 2 and y is 0, and no other points. That's what a tangent does to a curve. That's the end of example 6.